Welcome to the next Rise of AI virtual chat. My name is Fabian Westerheide. I'm an entrepreneur and investor with a passion for artificial intelligence. And we are doing this because I love to have conversations with leading minds in AI. And I want you to help to learn, to understand, and adapt artificial intelligence. This is episode number 15. Wow, it's number 15, and if you're live here, introduce yourself in the chat. If you want to check out the polls, you can ask questions all the time. I will collect them and read them out later. If you listen to this in the podcast, just enjoy. If you're watching this on the video, the same. And the topic today, which we have, is the next wave of AI. A little bit of a background. Deep learning came back. It's like a renaissance. 2014, it created a certain hype, but it also changed a lot. I mean, that because we speak today again about AI, that's because deep learning came through. And today we have a global AI industry. Government having strategies and investing billions, venture capitalists financing a lot of AI, enterprises adapting AI. I mean, AI is real. But what really AI is, what can we expect, where will it go? Well, these are topics for today. In 2017, Professor Hans Uskoreit from DFKI, he gave a talk about super AI, or strong intelligence on our conference, Rise of AI 2017. And he already said this will take a lot of time because we have a lot of intelligence, a lot of elements coming together, and we just have a tiny part solved of it. So it's a very complex topic. And then I read the paper of Gary Marcus called The Next Decade in AI, which was published in February this year. And he talks about the next wave of AI, and he calls it, we need hybrid, knowledge-driven, reasoning-based approaches centered around cognitive models. And that's not easy. I mean, it's not even easy to pronounce it, to describe it, and I think to fix it. And then Joshua Benjo said on a conference I attended last year, it's all about cognitive agents. So what actually is cognitive agents? How can we reach it? What does it mean? Well, that's why we have this topic here today. And my guest today is Professor Kristian Kersting. And he is a professor for AI and machine learning at the TU Darmstadt. He was prior active for Fraunhofer Institute. He was at MIT. He has a long list of awards from the more popularistic Deutscher KI-Preis, where he got 100,000 euros last year, to best AI papers, top 100 list, etc. He's the designated director for the Tensor Institute, which is a collection of over 12 AI institutes or universities in the region with 20 new professors. He will mention this later. He has published books and papers. I counted over 318 papers, so highly productive and creative. Just to read out one title, it means Discriminative Non-Parametric Learning of Arithmetic Circuits. If you haven't understand it, you're like me, I didn't get it either, but he has published hundreds of those, so he knows something, and that's wonderful. So let me bring him online. There you are.
Hey.
Hallo Kristian. Schön.
Thanks for the invitation.
I have the first question for you, which is, your most famous student, you mentioned him, is this guy, right?
Yeah. I mean, at least in Germany.
At least in Germany. So this is Rezo. He got more famous because he was criticizing a little bit politics and news. Still, I heard he studied at your department. He studied with you.
He studied in Dortmund, and he was back then already a very fascinating student, in my opinion. He did his master thesis with me. And the actual story is that after the lectures, I'm sorry, I'm still one of the old guys smoking, so we always had a cigarette together. Well, I was smoking and we were just talking. And so he was back then already a very clever person, trying to listen, having his own opinion. So it was a pleasure to get in touch with him and also supervising him a little bit. So that was great. And I think he's still doing a good job in a sense of, independently of my own political reasoning, I think it's good to get a little bit of discussion, right?
And I think it's interesting. Normally we have outsiders going into AI. I mean, a lot of consultants, business people. I mean, I'm an outsider too. I never studied computer science. I come from the business sides. But there we have someone who studied machine learning and he went into media and music. It's very interesting, and just as a curiosity. So, today we want to touch a couple of interesting topics. And before we go deeper into the topic itself, I would like to ask you, describe a little bit what do you do as being a professor for artificial intelligence? Because you told me Corona was even more busy for you than before.
Yeah. So maybe I should be very honest here. So the last half a year, and actually going further back, I was mainly busy with what you already mentioned, the Tensor Institute. And just to be very clear here, no decision yet. It's just that the state of Hesse, they decided to establish, or they want to establish, an AI institute that is not just at one university, but trying to really get together all universities and also applied universities in Hesse, because AI, you can do fundamental research, but you should also try to get this into industry, into society. You should really try to get more startups. So most likely we need an ecosystem, and that's the idea behind the Tensor Institute. And Tensor, because after the Parameter Institute, there was the Vector, or is the Vector Institute with Jeff Hinton. And so we thought, hey, let's go some more dimension on top of it. So it's now the Tensor Institute. But I should mention that if it comes, the Vector Institute also gave us a letter of interest. So hopefully we can build up a strong collaboration also with Jeff and all the other great people, also Gary Marcus. So now what I do? Well, because of Corona, everyone likes now Zoom and other online meeting platforms. So it was more like having one meeting after the other, a lot of political meetings. But typically as an AI professor, I would argue that you talk a lot to your students, you try to develop algorithms, you try to evaluate them. And if you're working interdisciplinary, you may also work together with people building robots and then really putting your algorithms into life, in a sense, into the real life and the real environment. And typically you're frustrated as a professor because you have big ideas, it doesn't work, but that's also the motivation, right? So you have the spirit of, it has to work. Come on, we have to get it right. And in Darmstadt in particular, because of Gary Marcus, because you mentioned him, we are working also we also have a Center for Cognitive Science, which for me is the twin discipline of AI. And so we also have a lot of chats with these people trying to understand what can we learn for AI, but what can they learn from AI? And actually we try to not distinguish them. We should just say, look, we are interested in understanding intelligence, and you need both, and some other disciplines as well. Okay. So it was just a lot of meetings because of the hopefully positively decided Tensor Institute.
And for how much are you still, you mentioned before that your algorithms you have written yourself or your team has written are in plenty of devices and out there. So just give an example, like where we can find a tiny piece of your idea or code.
Yeah, so we were working early. So that was all triggered when I was a student. Luc de Raad was joining University of Freiburg, and I was doing my tour through all the labs asking what are good topics for master thesis. And he said, look, I was attending a talk by Daphne Koller that maybe some people know, because Daphne I'm not sure, I think she was professor at Stanford, and now she's really into business and into bio and medical informatics and trying to help developing new drugs and everything. And she was giving a talk about one of the big issues in AI. How can you get methods that can deal with uncertainty together with methods that can deal with complexity? And within the field of AI, that means you're working with, let's say, probabilistic graphical models, or you may use some deep networks that can also deal with probability distribution. And you would like to get databases and ultimately logic together, right? So you want to have something like a high-level programming language that allows you to still deal with uncertainty. And so he was saying, look, I didn't understand all the details of what she was saying, but I think that's an exciting topic. Let's do something on our own. Let's maybe even do it better. And I thought that was wonderful, right? Not do exactly that, but more open, try to do your best. So this is where it started. And out of that, also during my time at MIT, we developed also something that via DARPA and Stanford went into Ziri, because if you have a dialogue system, you would like to understand the intentions of the user. And if you want to program that, you don't want to do that on the very low level, right? You would like to provide high level ideas, background knowledge about what could be the intention, why is this person asking that? And so they were using some parts of what we have done, at least in the early versions of Ziri. That's what people told me. We never got patents on that. We never got any money out of it, but that's roughly it. And so I guess at least on the first iPhones, many people have used our algorithm.
Okay. So let's talk about the news which came out. I mean, I have the feeling that since deep learning, we are like lacking the breakthrough. So for me, AlphaGo was one of those highlight moments, and then we had a couple of, but it's like there was nothing revolutionary out there. So everyone is talking about GPT-3. And I would like to ask you, why are all those people out there excited about it? I mean, criticizing is always easy, but what is exciting them?
Yeah, so what is exciting, if you grow up as an AI researcher in 80s, 90s, whatever, you realize how difficult it is to come up with a system that looks intelligent or smart, right? It's really, really not easy. Now with this GPT-3, what is happening is that you have the system where you can easily ask questions, or you ask to complete sentences or to continue writing little stories. And the output of the system is pretty amazing. So we stay on the positive side, right? So for sure, you could also say there's a little bit of cherry picking in there, but it's simply amazing how much they can get out of this data and the huge model that they have.
But what is...
You then look a little bit closer into what they have done actually. It's amazing because it also resonates well with old stories, but just implemented in a new way, in a more differentiable way. We call it differentiable. It's the, if you want to be the cool kids on the block, you don't want to call it deep neural learning, but you call it differentiable programming, because that's what is really at the heart of deep learning.
Differential programming.
Yeah, let me explain it. It's pretty easy. So you sketch your algorithm. So and that's also going back to the three waves or the third wave. In the first wave, you are just writing down algorithm by hand, right? So you have to think about every eventuality. You code it, you test it. It's a lot of work. If it works, it's good because you fully understand what is going on. But it's really hard. Now, in the deep learning area, what they realized is if we can get major programming blocks differentiable, which means you can compute a gradient, and you would like to compute a gradient because now you can sketch an algorithm, and then using data, the gradient will tell you how to change the sketch that you have provided, how to instantiate it, how to change a little bit these parameters to get it tailored toward what is written in the data or captured in the data. So
that was number 2, phase 2.
That was number 2. Now, number 3 should be that you should be a little bit more human-like, at least in terms of communication and reasoning capabilities. That's also what Gary is stressing. And in particular, you should be able, a little bit like the human, to recognize new situations and potentially even adapt to it. If now something breaks down here in the stream, we will not simply continue. We will simply also not simply break down. We will try to find a solution to adapt to it. And if it's just smiling and saying, hey, damn it, we will meet again, we will find somehow a way to deal with it. And that's pretty hard with still computer science methods and AI methods, right? We are good at specific tasks. We are amazingly good. And GPT-3 now, coming back to that question, at least for the textual domain, is giving you the impression that the first time we may have a system that can deal with many, many different tasks, even tasks that you did not have in mind when training the system. And that is something that seems to be very essential for a truly smart system, right? So if you were talking about AlphaGo, AlphaZero, well, that system was pretty amazing at chess and Go, but it's not good at, I don't know, cooking. It's not good in driving a car, right?
I mean, we know this problem of that it's all narrow AI or very focused one and transfer knowledge doesn't work. But is GPT-3, for what can I use it? I only know it that people are writing blog articles with it.
That's a question that we will have to answer now, right? People just realize that it works well in asking several questions, even about topics you had not in mind. Now, how to monetize that, how to turn that into other applications, how to maybe even put that onto a robot, big questions. But that will start now. It's not that you instantly have to get through the
Is it only an NLP tool, or is it also a tool for all other fields like image processing, for example?
Well, it's definitely not for image processing as it is right now. People are trying, of course, now to use a similar architecture underlying, now also on images, and soon you will also see that you have multimodal versions, so you can have text and images and whatever. So it's all about these transformers. That's how it's called, right? It's called a transformer network, or layers, depends on which perspective you want to take, whether you take the whole network or layer-wise. And the transformers, if we want to stay very simple, it is a differentiable version of something like not exactly true what I'm saying now, but just to give you the gist, it's a little bit like a differentiable version of a nearest neighbor search. Not much more. So nearest neighbor means, given something, you try to find the stuff that is closest to it, one or many of them. And now what they do there, they have a big dot product implemented in a differentiable way. I'm simplifying here because I think that the details are not so important. And it's amazing how much you can do with that. Now you can transfer the idea to other domains, but we still have not a single system that can deal really now with images, that can even take actions or make actions that interacts with the environment. We don't have a single system that can listen to you. Maybe we now have a better idea how to set it up in the future, but you still have to set it up. And then you have all the little other interesting things. But some people complain and say, oh, but how can we make sure that the system always does what it should do and not does anything crazy? It's an issue. On the other hand, some humans unfortunately also go nuts in their life. So, right, I mean, what I want to say with that, if we want to have an intelligent system that never fails, that sounds to me like a contradiction.
Yes,
For me, failure is part of intelligence in a sense. And that's why we want to have the third way, because you want to learn from your failure, right? And you may think of reinforcement learning, but there might be also other ways, because we have to get reasoning in there. I mean, we as humans, I'm not just doing simple reinforcement learning. I'm also thinking about what I have done. And I may skip some of the simple, let's redo and get the experience again. And I'm projecting and I'm saying, okay, I will not do it again.
Let's
so
put
I think the next because you talked about big breakthroughs. So first of all, in other scientific disciplines, it's not like you have every year a super breakthrough. So give ourselves a little bit of time, but I think you will see more breakthroughs at the moment where we get reasoning and learning together. And there are some approaches already, and it's now about scaling and making it more practical.
And the reasoning part is important, one for check and balance, for due diligences, for opening the black box. We call it explainable AI, and we had 2 talks about this to cover. From your view, from scientific view, I mean, you're doing AI longer than the hype exists. I mean, the hype was increasing, but I would say most politicians didn't even know what AGI means 3 years ago. Yes, and today most don't even know it yet. So for you, do you agree that deep learning was the thing which pushed it forward and opened the box of having more resources and everything?
Yeah, it's a combination what was happening. So I often hear that people say, oh, this is an old story. There were already neural networks in the 40s, and then stochastic gradient, already in the 60s, 70s per se. And then all of a sudden there was backpropagation. And then depending on whom you're listening to, you had backpropagation already in the 70s, 80s, whatever. It's all the old story. Well, sure, mathematics is also pretty old, and the idea of intelligence goes back to the Greek people and maybe even further. So
yes.
what was really different now is that also the hardware was changing, and we were lucky enough that there were some people that understood that we're not giving up to implement maybe even already existing algorithms in the beginning on new hardware. And all of a sudden, you could do things that were, well, you didn't believe it was that easy before. Now, that doesn't mean that the question of intelligence has been solved, because we also know that humans can do it with so less data, right? So deep learning, on average, if we are not making use of pre-training and transfer learning and everything, is pretty data hungry.
Yes.
So we should try to understand what can we learn, for example, from humans, in order to be more data efficient. One question. In terms of hardware, CPUs, GPUs, they are not really energy efficient. Our brain is pretty energy efficient, right? So there are so many interesting research challenges still ahead. So now, anyhow, let's go back. There was this breakthrough in make it happen. And then another thing that I think is really important is that there were companies involved. Because why is that important? First of all, a company like Google can afford to put engineers on the topic and develop something like TensorFlow. They were not the first going for a framework for deep learning, but they can do it in a way that it's maybe a little bit easier to use. They have advertisement, they can build up a brand. And then all of a sudden, and that's for me the real difference to what was before, you could do something like machine learning without first studying machine learning. It was made easy. And that's always a key to get something into the mass.
Democratizing technology. It needs to be usability, needs to be very easy.
Yes, and still we have, of course, also to work a little bit more on that part. But I think that's really important. And that's why for me and also for many people in Darmstadt, we believe one of the big issues is now to get software engineering for AI, because that's not existing, right? And if we now want to make it that programmers can build these amazingly new systems, we also have to support it. And it seems to be completely different. I mean, how do you debug a learning system? But so I want to say it's really something where you can get whole of computer science again back together, right? Because it's software engineering, you may have databases, you have hardware, you have so many different subdisciplines. It's amazing because you can talk to all of your colleagues.
I agree. From a niche topic, AI, it went into a mainstream topic, which is now, I call also ethics, philosophy. We speak about strategy, project management, policy, morals, ethics. I mean, ethics belongs part of it, yes? So the whole topic expanded huge.
Sure, but just to be clear, I mean, if you look at the Dartmouth workshop, where it was all invented in terms of at least the term AI, you had cognitive scientists involved, you had philosophers being there. So what I want to say is the origin, it was always interdisciplinary, but then somehow, mainly in my opinion, computer science was pushing it over the years with all the big conferences. And now some other people are coming back, and I enjoy that. But it doesn't mean that you always have to talk to everyone, right? You sometimes also need, so to say, your way. But definitely, and in particular, ethics it's a wonderful and important problem. Although I would argue that we need much more ethics from both sides. So the more classical one that is coming from human science, maybe, but we need also people that understand what is technically at all possible. And there in the US, this is already much better. I think in Europe, we have super interesting, super strong people, but that is developing right now. And I'm very happy that it's developing. in particular in Germany, however, we have to be careful that we are not discussing on debating ethical AI by having this idea AI is already human-like, and we use the human as a example for AI, you know, or as a, not example, but how do you say that? As a substitute,
as a little bit as a role model. So I once
yeah.
saw as something, if AI is written on PowerPoint, you know, it's fiction. If AI, you know, if machine learning is written in Python, it's code. You know, it's like expectations. I know people out there writing on the slides, you need AI to do this, and we will come over the next virtual chats more on the application, how to do it, how to run it. With you, I would like to touch a little bit. For example, Ayosha Borchardt is in the chat too, and he wrote, we need hierarchical planning. Honestly, there are so many ideas out there which I don't fully understand. So I don't understand the full problem. Deep learning, I get it. I mean, that was one huge technology which then got more detail, which pushed it. But I have the feeling we're now trying to figure out how to put more pieces together, what's next, but it's also going in so many directions. I've seen, I mean, the paper from Gary Marcus is only one of many. What's coming next? Can you describe a little bit why we are kind of stuck? It feels like we are stuck. And maybe why, or why it only feels like, and we are doing a lot of impact. It's just.
But I don't think we are stuck. Sorry. I mean, this is like a little bit like people talking to me saying, the next AI winter is around the corner and it has started already. No, what has started is maybe sometimes people are frustrated because we have these super high expectations that we have human-like systems already. But if you look, what we are doing is there are so many success stories of making use of AI in real world, in the medical domain. We have done a lot in agriculture. And if you think about climate change, there's so much interesting combinations of debate. So there will not be an AI winter now, in my opinion, because you can't ignore that.
I fully agree, and I always say 99% of AI application is not done yet. So if we stop doing research, we still have enough to do for the next 10 to 20 years. I agree. For me, it was just the feeling on the researcher side that it's less attention focused. Like oh, that's the new excitement. Like in our media awareness, like jumping on the new things.
Well, I think there are a lot of papers that should get more attention and that have the potential. It's only the question of if you're at a university, whether you like to put a lot of attention on it, because you are sometimes, at least in Europe, also this more shy person. You say, hey, if it's good, it will survive. It's a different culture sometimes. If you go to the US, they hype it a little bit more, maybe, which I like. I mean, I was at MIT. I also got the idea that you have to do advertisement. But in my opinion, like GPT-3, wow. I mean, you could say it's a breakthrough. Doesn't mean that we have arrived at AGI.
No.
To stay with your teacher, right? But it's definitely something, wow. I think all the stuff about the ethical part, I mean, there was this very nice science article about now maybe already 3 years back, about how they capture the stereotypes of us humans if you learn from text. For me, that was a very strong and important paper as well. Unfortunately, it got a little bit discussed in public in a weird way, because it was now saying, oh, machines are racist and machines take over stereotypes. But keep in mind, it's a mirror of what we are doing, right? And it's nice that we have now a tool to show that we are maybe not perfect. And so now it's the question, and this is where, again, we need then the discussion with other disciplines, what to make out of this result. But it's not, in my opinion, a problem per se of AI, because it's more a problem of what we are doing. And this is a big debate currently going on between, is the data bias, are the algorithm bias, how do we deal with biases? Can we get them unbiased at all? Super interesting, super important discussion, and definitely for the field, in my opinion, a breakthrough. Explainable AI, it's in that sense a breakthrough, although there's so much we still have to do. But I still recall when I was a PhD student, there was not much chance to work on explainable AI, because people would say, no, you either know
it's
your algorithm or it doesn't work.
And the problem was a little bit different. I mean, I agree. It expanded to many subtopics and new topics, and I mean the whole AI adoption is a huge new field. I mean we have plenty of homework to do. Let's jump back to where we're developing on the research side, because
Yeah, let me, you raised this question, hierarchical planning, and why do we need all these different things? Look, to a large extent, AI, not completely, but there's a subpart that is also about engineering such systems. Now, as an engineer, I think I don't like to just use deep learning the way we do it right now, at least in the simplest case, where you say, here's a big monolithical, big block of a neural network. I need enough data. I get lucky if it learns it or not. As an engineer, you know, I once was talking to Ad Artsen. He's a neuroscientist, a pretty big guy there. And he was saying, look, I'm a neuroscientist. I have to understand the human brain. But if I have to develop a robot that should also operate at night, I could use infrared. I don't have to now understand, damn it, how could I do it without infrared so that the human or the machine can operate at night? So this is, I think, what you want as an engineer. If you want to do planning and you have a great planning algorithm, for example, for hierarchical planning, if you could make it and use it, that's awesome, because then you know for that part what's doing. Now, the challenge is, and that's why I was talking about this programming for AI, is how to combine the planner, which is maybe a little bit more symbolic, with this differentiable deep learning. But this is happening now. There are papers trying to combine. We try with the third wave, we try to push what we call systems AI, so a little bit like systems biology. Each cell is one of these AI algorithms, but you can put them together. And how do you do that? What are the mathematical foundations for doing it? Can we still provide guarantees? And if we have that, that's cool, because then you can put as much white boxes in there. And only for the parts that you don't really know, you are happy to make use of the black box. I think that's what you want to do as an engineer.
And this is how actually do you research? I mean, I'm curious. How do you research this? Like, do you do a lot of testing? Second, if you publish it, is it like then accessible for everyone? I have the feeling that AI knowledge is more accessible than other technologies because it's less based on patents and more on papers. But just a feeling. I have the feeling that, especially China, for example, they participate a lot from our research, and in other fields they couldn't do it that fast.
Yeah, I would argue that most of university people, academia, they don't care much about patents. Once in a while you do it. If you're a researcher at Microsoft Research, maybe also because we have one listening at DFKI and other places, you care about patents. In Europe, sometimes we have an issue because if you want to go for a patent in the US, you know, it's an invest. And if you're at an institution that is maybe not as rich, you maybe don't do it. At my lab, we like open source and open science, right? We put our code as much as possible online so that people can try. Yeah.
And how do you now combine? I call it old-fashioned AI and the new AI. You know, you call it symbolic plus deep learning.
You explore different ways. One simple way, and you talked about AlphaGo already. It's a very simple hybrid system, right? You have MCTS, so Monte Carlo tree search. So you do a simple search, but in a stochastic way. And then in order to evaluate, because you can't check the whole search tree, you have at some point, you drop some of the subtrees and so on. You make use of deep networks to capture this evaluation function in a sense, telling you how promising something looks like.
Okay.
It's a combination, right? What we are currently doing is we come from what is called probabilistic programming and statistical relational learning. So you have a little bit of a combination of logic and uncertainties. And now you can put some, let's stay in the database analogy. I think that's easier for many people. So some of the tables you can now replace by a deep network. And then the question is, how can you now propagate information? And it's again the question of the gradient, but because we are making use of technique that provides a gradient, it's for now not a big issue. So you can have a system where some parts are neural networks, some parts are these arithmetic networks you mentioned in the beginning. This is, you can view it a little bit like a deep neural network, but just for probabilities, and you don't have to use any analogy to a neural network, but it's the very same idea that you would like to have a deep system in order to deal with joint distributions. And then we have also the logical part that can deal with uncertainty coming from statistical relational learning. And we combine all of them based on work that also colleagues have done at KU Leuven, but also at Uber and so on. So many of the companies, they also understood that they need a programming language, a high-level programming language, because otherwise some parts of AI will not scale, not at least the way you would love to have it scale, right?
What do you mean with programming language? Do we speak about Python or do we speak about tools below?
No. We ultimately we would like to have, for example, Python or your C, C++, F#, whatever you prefer, but we would like to have this language dedicated to AI. So the first step could be that learning algorithms are first-class citizens of these languages. So let me give you an example. You can run machine learning in the following way. You instruct the machine to, and you say, okay, download images from there, classify into female and male, and then send everyone who is a male, send an email. So I have described something where you definitely need machine learning without even calling it machine learning, right? Even when specifying is that a support vector machine I'm using for classification, is it a deep network or whatever. And I think this level we have to reach in order to really democratize AI. And the machine should make the decision. Should I use a deep network here? Should I use the SVM for that particular part? Because if you talk to, well, and I'm only talking about biologists now because we have this collaboration on deep phenotyping, so trying to understand plants and how they react to stress. You know, they are not programmers. They don't want to go even as deep as TensorFlow and specify the architecture. So essentially, you could also say this is something like Outer ML or Outer AI 2.0, right? So you need even the next level. But maybe we need a little bit of a programming language because you still have to instruct the computer. At some point, I guess we will have natural language instructions for computers, but that's not there yet. But that's why you need a high-level language, and you can view it really, for example, Python. Python is now a scripting language, but you may also go for any other high-level programming language. Definitely, I feel sometimes we are a little bit more like assembler for AI right now. Not exactly. TensorFlow managed to get away from the assembly, but it's still not that easy. And it's not that easy to debug if you're not an expert. And you want now systems that tell you, hey, maybe you used the wrong architecture here. Hey, maybe you don't want to use Adam as an optimizer. You want to use something else. And hey, maybe you can check here and I will do the decisions for you. You don't even have to care. Evaluation. And coming back to ethical part, how much can we automate there so that we avoid that you do something wrong in the evaluation? So many interesting things.
So much to do, so much to do.
Yeah, but it has been also already something done.
So I have two thoughts. First, we can get inspiration by human intelligence for AI, but I don't believe we recreate human intelligence. I personally believe machine intelligence will always be different, and it will be surprisingly different and uniquely different. Like biology itself has thousands of solutions for different problems or sometimes the same problem. I just say we should stop saying AGI is the goal and we want to have a human-like AI. No, it will be very different and beautiful and scary different at the same time. But that's my view. You mentioned this before, like expectations should be matched to realism.
Yeah, well, first of all,
you don't like AGI as a term.
Yeah, no, so, okay. So I grew up as a very standard, boring AI person. And if you read any introductionary textbook like Norvig Russell or whatever, they don't distinguish between general intelligence or AGI and AI because that's already part of AI. So why do I now have to create a new term even for something that is already covered? I don't understand that. But at some point you start to adapt and you say, hey, use that term if that helps you, if you enjoy it, fine with me. Now, about the comparison. So first of all, I like if you say already human-like, because it doesn't mean it is like the human. It means more like, okay, we may take inspiration from humans, because AI can also be different. I'm fully with you. I mean, imagine we are trying to get self-driving cars, and our only goal is to be very much like exactly the humans.
Oh, terrible idea.
But we haven't achieved anything. You will have the same number of accidents, maybe. You will have the same number of traffic jams. So at some point, being different from humans is good. We also, if you think of interpreting fMRI, or maybe at some point assisting in very, very challenging operations, medical operations, maybe you don't want to be human-like, right? You want to be very precise and reliable. And I'm sorry, humans in that sense are not as reliable. But then if you really want to have a truly intelligent system, in the sense of a human, so a general problem solver, right?
A general problem solver, right.
If you want to have that, then maybe you can't be perfect everywhere. Maybe that's the trick, actually, to become a general problem solver. Who knows? But now my main point was, because you said you don't want to be like humans, but keep in mind, cognitive science is making the assumption that we apply information theory and computer science to the brain and to the mind and to understand cognition. So just to make it clear, I mean, when you develop a new algorithm, that may also help at some point to understand better how we function and why we behave the way we behave. So I would disagree with you. I would argue, okay, machines do not have to work like humans. But I see humans very much like biological machines. They, of course, do not run on. Yeah, but as an AI,
it's called wetware.
I talk about machines. I don't care much about the. So there are the 3 levels of David Marr. And you can debate them a little bit, but it's first you would like to understand what is it computationally that we have to solve. So you want to see mathematical formulas. Now, after you know what you have to compute, you can ask, how do I compute it? That's the question for an algorithm. And then we have this pseudocode algorithm, and you can ask, can I implement that on a standard computer for Neumann? Can I implement that in a biological system? So you should distinguish between them. And per se, AI is just about algorithm and the computations. And sometimes you can also change now the implementation. And of course, that may help also impact on the other levels. But per se, come on, we are interested in algorithms, and we can abstract from the underlying architecture.
I like what you said, because I had this with Erik van Möller, the discussion that we are biological machines. I mean, you can reprogram your brain, we are working in patterns, and I think a lot of AI is inspired by this form of intelligence. But then with, for example, object recognition, we discovered that they can see with infrared, they can see way more data, they can be faster. I mean, we currently have, like in Israel, AI detecting movement patterns and sweating, and they discover in China if you might have corona, or if you are a terrorist in Israel, so something human can't maybe see, they get even more data. So it's very interesting. We also had this discussion that AI is mainly a tool, and human plus AI are the most productive out there currently, not for all fields, and that we go there. So I always say, the moment we have a true AI, AGI, I don't even know if I want this, because it won't stop learning. You know, it can. Some people out there have the fear that we can lose the control, that, you know, it can go rough or amok. And we spoke about this weaponizing AI 2 weeks ago in a virtual chat, where you have this risk out there too. And it's interesting how they make no decisions automated currently. Everything is done by humans, and AI has to wait for orders.
Well, but on the other hand, for me, and it's maybe now only thought-provoking, it's for me always interesting whenever you talk about AGI, and I'm using this only now because I'm talking to you, the term, then people say all of a sudden, oh, damn it, because it's truly intelligent, the first step it will do is to get rid of humans.
Why?
And that's I don't understand it. It might be also because it's truly intelligent, that it understands only together we can save the planet. But that option seems to be never discussed. It's so clear that we have to get rid of humans. And for me, that is a projection of what we humans think, what we would do if we have general power. And so again, it's a little bit like with the with machines taking over our stereotypes, and then we blame the machines. I think this debate, to a large extent, is always actually about us, and we use AI as a good excuse to talk about ourselves without naming ourselves.
Mm-hmm.
So for me, that is not an implication. And to be honest, and Eric Horowitz is always saying that, I think so far AI has, if at all, saved more lives than it killed. And still, we're talking much more about where it could maybe kill. Sure. And yes, I have also signed, as so many others, the letter that we don't want to have AI and autonomous weapons and everything together. But then, to be honest, and that is what I always want to ask Elon Musk, and also I wanted to ask Stephen Hawking. So why do they blame AI if they could also blame the weapon in first place? The person who is building this weapon, isn't he or she as much in charge than the AI? But all of a sudden we have accepted, yeah, weapons, that's okay. But why do I build weapons in first place? I don't understand that. But it's just me.
I had this discussion, and we need weapons because it's a how do they say, it's game theory, yes, and if one starts having weaponized AI, everyone else needs it too, at least to defend. It's like nuclear bombs. It's this strategy game behind.
I understand that part, but it's fun to see. We accept that they are weapons, but we say now it's really horrible if it's weapon plus AI. And we start blaming AI for it, but we should blame also the weapon and the weapon industry for it. And we should blame us humans because we follow game theory here. So I just want to say, always, please let us blame everyone. It's not just AI. And we should not just be happy that there's a new player and therefore we can blame her, it, him, whatever you want to call AI.
So you said two things I noted. First, you say AGI is more the idea of having a problem solver. We humans are very good problem solvers. We need little data to fix things, and we need very little data to memorize it because our brain is, by the way, not active all the time. It's just very focused and highly superficial. But then you said, speaking about truly intelligence, what is for you truly intelligence? Because if I listen to you, we are not good in math. Yes, like calculating calculator can be faster than us. We are not good in driving. We are very terrible at a lot of things. What is for you truly intelligent?
So I can tell you, for me, true intelligence doesn't mean that we have invented the flying spaghetti monster that is controlling the world. Truly intelligent doesn't mean that you are perfect at everything. For me, for example, an average human is truly intelligent already. Because for me, that is the amazing part, that you're a general problem solver. And we have this capability, if I fail somewhere, I can ask one of my colleagues, one of my friends for help. This is for me really smart. Smart doesn't mean for me always optimal. It just means that over the long run of your life, you do a pretty good job. But that's my view of what is intelligent.
And is this the main difference also to the rest of biology, nature? Because I have the feeling that a lot of animals, they have solved problems, but a lot by reproduction, like by mutation, reproduction. Very few animals are able to use tools. Few, but some. And that's like the huge gap between humans and the rest, because we are using tools, we're using language, we're having paintings and everything.
Sure.
Still saying that we have a lot of intelligent animals out there. I don't say they are not intelligent, but after your definition, they are not that truly intelligent.
I don't know. I mean, if I think of apes, some of the apes, amazing, right? And there are the classical studies that show if you take a 5-year-old human, they can't solve the problem, and then you take an ape, she is solving it instantly, right? There are so many. I mean, I don't want to make any commitment to saying that animals are not truly smart. I think we also get more and more insights there. And sure, you may not have the same tools. A bird has not really hands, and now we start blaming the bird for not having hands. Still, they build their nest. Pretty amazing, right? So, I mean, and you grow up also as an AI person, that you say there are different grades of intelligence, right? So if you understand what is an agent in AI, you also, some people say a thermostat, something that is controlling temperature, you could argue it's an agent in the sense of AI. It's maybe not the strongest agent.
No, it's an agent.
We have a sequence of different agents, and in the end, you have maybe something like knowledge and reasoning and learning-driven agents. Okay, but the other ones are still part of AI, which is also sometimes, I think that is contributing sometimes to the confusion about AI, because it feels like everything is AI and therefore it's not a good definition. But that's not true, in my opinion. It's really, we want to understand what is intelligence. And in order to understand intelligence, you also have to understand what is not intelligent. It's part of the game.
So two thoughts. First, I watched on Netflix the documentary Explained, and they had one about intelligences, and they describe, I think, 5 or 6 forms of intelligences, which we human all have, animals often have, but it's like emotional intelligence, it's like abstract intelligence, like, you know, time and so forth. So one thought is, how can we implement this into AI? And the second is, what human and all other forms out there, even trees, they have reproduction purpose. A lot of everything in the universe is a lot about reproduction and growth, and a lot of energy goes into this. So what we are missing is the motivation for AI. I know that you can motivate AI by solving this problem and then you're giving it incentives to optimize on this, but do you think we need inspiration there too, to have a long purpose motivation for AI out there, so it starts evolving even more?
So let me clarify. I think we are jumping between different levels of abstraction here. So you're talking about reproduction. Reproduction is one way of doing classical mathematical optimization.
Okay.
Right. So you say I'm looking at these parameters. Now I have also another version of the parameters. So I have these different individuals. They perform in an environment. We have specified an objective function, and we can clarify which of them are good or bad. In reality, they die or not. Let's stay very simple, right? And the ones that are dying definitely were not good enough. So, you know, in evolution, you go for the ones that survive in the one or the other way. So you can phrase that as a mathematical algorithm. And it's called evolutionary algorithms. But you can also make a direct link to very standard gradient-based optimization. So there's no contradiction. Now, additionally, there is one paper by Papadimitriou. So the Papadimitriou is one of the superheroes in theoretical computer science and many other parts. That's really an amazing person. And he wrote, I think, in the Journal of Mathematical Biology, he wrote a paper with, it's not the title, but in the abstract or somewhere, it is essentially written like that. Why sex is not good for optimization.
Okay.
And with reproducibility, depending on what you're implementing, which reproducing operators you're implementing. So if you have a crossover where you say, okay, I'm taking 2 individuals and I'm now mixing their genes. And so a little bit like what we know from very classical school genetics. What does it mean? Whenever you're close to the optimum that you want to reach, you throw away half of it, and you're happy to take half of bullshit or not as good again into your model, right? So that is why reproduction is much more about being robust. You want to survive, you want to be flexible. But again, you can formulate that as algorithm in an algorithm. But if you want to reach the optimum, maybe you want to use other optimization techniques.
Like
now,
gene editing, cloning with gene editing, growth babies. Yes, I agree. Regarding time, and you mentioned robust AI there too. Like,
no, go ahead.
No, so reproduction, you said, it's not the optimal thing, but it's robust. So it's not the best result, but it works.
Yeah, it's like in science as well. Once in a while, you have a superstar, a genius, and he will make this breakthrough. But on average, to survive as a scientist and as a scientific discipline, you should be also robust and not collapse if there's someone saying, oh, AI is not good, and then oops, and we collapse all. No, you need to be robust. You have to deal with this little attacks. It's also good because it helps you to reflect and adapt and to also check where you want to go. And I think we don't want to go into the regime where you enter maybe the super optimum of everything, and then maybe we're not happy with the optimum. So I'm happy if I can sell a product that will survive long, and for that you typically need robustness. And in particular, if we talk about AGI, because you don't know what questions people will ask the system. If you think of a chatbot, you want to be robust to all the stuff that can be entered there, even not the intended input. One question. Other question, if you're driving, if you want to have an autonomously driving car, you may not, when developing it, think of all eventualities. So again, robustness means you are not failing or killing people only because there's a situation you are not really used to or it is too far away from what you have seen. So in that sense, robustness is important. And again, it's maybe not the optimal solution, but it's a long debate. What is optimal? What is robust? Because you can always take a different level, and then the robustness is part of your optimization, and then all of a sudden it is part of your objective. Yeah, let's relax there. You just want to have systems that are not going nuts. Something I would also like to have for society.
It's November is coming. Regarding time, I shortly summarize. So what I took out is also that you are working others on these hybrid solutions where you combine different models, as you call it, the third wave, to make it, for my summary, to make it more usable. Yes, like one key thing is not to combine more skills, to make it more modular, but also to make it more usable is one goal, so more people can use it.
Well, more people, but you will be surprised how much more breakthroughs you will see if you can do reasoning, learning, acting, all these things together. If you can quickly combine reasoning and learning, you will get even better deep learning systems that we have right now. So it's both.
So let's jump. Last thought. 2030, in 10 years, we know where we are today. Where could we be in 10 years, and what is needed? Like high level, so everyone out there knows what the milestones could be.
So for me, where we will be, I think one of my dreams is that we have all accepted per se AI systems, and it's a little bit like when cars were introduced. There were devil's engines in the beginning. Now everyone drives a car. I hope we will fix the climate things. So I hope that we have all enough knowledge to understand that AI has so many positive aspects. That means we need also enlightenment, not only in the academics, not only in the industry, but also at school, in the general public about AI. I mean, we have to teach AI parts and also programming and other parts of computer science at school already. If we have that, then I hope we will see that it actually helps to make the world a better place. And that already in 10 years. It's a little bit challenging. Yeah, I understood. Maybe in 15.
No, I like the last sentence because we need more training for this, more awareness, and to make the world a better place. I think this is a beautiful last sentence. Kristian, I thank you for your time, your insights, your knowledge. And everyone else, stay in for a minute, and we will talk again. Thank you for being here today.
Definitely. Please invite again, and I hope I can also invite you to some of the tensor events if it gets accepted.
It will. Okay. Pressing thumbs, and I'm very optimistic. We'll talk about this. Wonderful.
Thank you again for the invitation.
Have a good day. So everyone else there. Next virtual chat is next week, 11 a.m. again, and it is with Dr. Uli Waltinger, who is head of AI Siemens Lab, and we will talk about industrial applied AI. Today it was on purpose, theoretical and high level. We will talk about how can you apply AI, also how can you apply it in the industry purpose. I'm very curious to see what applications are, which is already working out there, so join in, sign up for it. Also, I would like to paint out that we have the summit in November, 17th and 18th of November. It's a hybrid event, so there are roughly 6 tickets left to be on in person here. It will be here in Berlin. There will be 3 stages, and you can be there in person. It's limited to 100 people, but it's unlimited virtual. So if you want to have the same experience like in the virtual chat, you know, with Swapcord and the networking, you can buy a stream and networking pass, or you can just watch for free, but then you can't comment and can't ask questions. So get yourself a ticket for this too. And that's it. So stay home, stay safe. I hope to see you next week again, and thank you for tuning in this time. Have a great day.